Alright, hello Algebra 2 classes. This is the 6.3 video on solving quadratics. This is an extension of what we were working on in 6.2. This is the packet that you guys received in class. If you are in F block, you guys will get this packet during class, and you guys can work on the flip lesson then to work through it. If you're in E block, you guys will do this lesson with me and stuff, and we'll walk through all of it then. This is the homework assignment. 6.3 is page 318 assignment, going through these various problems and stuff. I'm going to try to keep this video short. 6.3 really concentrates on something called the quadratic formula. As a formula, this is very algorithmic. You're just going to identify some numbers, you plug them into a formula, and it gives you some numbers out. So this lesson should go fairly quickly. Let's talk about what we've done thus far. So we're still working on how to find the roots of a quadratic, which boils down to how do we find the x-intercepts of a parabola. Okay, we have two ways of doing it so far. We've done it by graphing. This is largely our calculator approach. We plug it into y equals on a TI-84, and we get little graphs, and then we identify where they cross the x-axis. The next way is by factoring. Factoring is a little more specialized because it only works in certain cases. It doesn't work every single time, and I can show you guys examples. You'll see examples of that today in the examples I'm going to show you guys. This third one on here, we're actually not going to cover this one. This actually leads into something called completing the square, and I can show you guys an example of that later. We'll come back to this one, the solving for x by square rooting. It's something I know is extracting square roots. Don't worry about that for right now. We will come back to that at a later time. Okay. So let's move forward here. So the big takeaway from today's lesson is something called the quadratic formula, which you guys will see here. It is this right here. X is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Let's talk about how you use this thing. We will talk about where this comes from next week when we go over completing the square. For right now, it's just a formula. I'm going to give it to you guys, and you guys are going to just do some basic calculations with it. Okay? So we have our quadratic formula. We're going to do this first example that's on the sheet. So we'll do example number 1 here. So we have x squared minus 10x is equal to 11. The first thing we need to do is we need to identify what a is, what b is, and what c is. We did this when we were doing axis of symmetry, when we were first graphing quadratics. We're going to go in a little more depth with it this time. We didn't use c for anything when we did axis of symmetry. This time around, it actually is really going to matter. First thing we need to do is make sure that this is equal to 0. So we're going to subtract 11 from both sides. Get x squared minus 10x minus 11 is equal to 0. And we'll go ahead and identify a, b, and c. A is equal to 1. B is equal to negative 10, and C is equal to negative 11. Plug everything into our formula here. So, again, we have negative b's, so wherever we have a b, we're going to put in negative 10. Everywhere we have an a, we put in 1. Everywhere we have a c, we will put in minus 11. And we'll go ahead and plug all those values in really quick. So, x is equal to a negative 10, plus minus. I'll explain the plus minus thing. When we get to the end, we'll talk about that. This is really representative of two numbers. Why it's plus or minus, we'll talk about that next week when we do completing the square. So negative 10 plus minus the square root of negative 10 squared minus 4 times 1 times negative 11, all divided by 2 times 1. And then just use the order of operations, and we'll simplify the whole thing out. So negative times negative is positive, plus minus the square root. Negative 10 squared is 100. Let me rotate this so you guys can see this a little bit clearer while I'm filling this. There we go. That's better. Okay. So, where were we? Okay. Negative 10 squared is 100. 4 times 1 is 4. 4 times negative 11 is negative 44 times another negative is a positive 44. All divided by 2. Simplify the square root out, so we'll get 10 plus or minus the square root of 144 divided by 2. Square root of 144 is 12. So 10 plus or minus 12 divided by 2. Like I said, this is really two numbers. This is really, this whole form right here is really 10 plus 12 divided by 2 and 10 minus 12 divided by 2. So we get two numbers out of this. 10 plus 12 is 22. 22 divided by 2 is 11, so there's our first answer. 10 minus 12 is negative 2. Negative 2 divided by 2 is negative 1. So those are our two roots, our two answers for this. It happens to be in this case that this is factorable. You guys can do an x-man here, and you will end up with x minus 11 and x plus 1 is equal to 0. Set them individually equal to 0, so x minus 11 is equal to 0, gives us x is equal to 11, which correlates with this answer. And the other one is x plus 1 is equal to 0, so x is equal to negative 1, which correlates with this answer. So it's consistent with the system and the rules that we've come up with. Yay, cool. So that gets us to the first example. We have a couple of things that we need to keep in mind when we're using the quadratic formula. The quadratic formula always works. Okay, this is the sledgehammer. This is the method that will always give you the roots of whatever it is you're working on. So this always works. One of the byproducts, though, of this is it works specifically with quadratics that don't factor. And there is a caveat that comes with that. If it doesn't factor, then that means that you're going to start getting really ugly answers. You're going to start getting answers that don't work out. We'll do another example here in a minute, and you guys will see that. The answers you're going to start getting are going to have square roots in them, or if you stuff them into your calculator, you're going to get these really, really ugly these ugly decimals and stuff. We'll talk about how I want you guys to write your answers down. I want you guys to keep the answers as clean as possible, which means you're not really going to use decimals here. So ugly answers, specifically things that are going to be decimals. Let's go ahead and let's do another example of one that doesn't work out pretty. All right, so I want you guys to go ahead and do example number 2. Do example number 2. Identify A, B, and C. Okay, I want you to fill in the format and then get your answer. Okay, I'm going to do it here in the background, but I'm going to speed up the video to go through it, and you guys just match your work. This is what you guys should get for the answer in the end. All right, so here goes. We're going to speed up the video just a little bit. All right. So there we go. We confirm the answer that I've got here. You should have ended up with 8 plus or minus the square root of 152 is equal to 4. If you stuff this into your calculator, so if I do this really quick here, we'll do the plus answer first. So we'll do 8 plus, so 8 plus the square root of 152. And we're going to divide that by 4. I get 5.08, really ugly answer. Okay, so 5.08. So this is approximately 5.08. Okay, this is not the answer I want you guys to give me. Here's what I want you guys to do. If you ever end up in a situation where you have a square root that you can't work out, it's like the square root of 152 is nothing pretty. It comes out to 12 and a whole bunch of decimals. Let's get this so you guys can see it. It comes out to a whole bunch of nasty decimals here. Whenever you end up with something like this, just leave it as the square root. So this is the answer I ultimately want you to give me. I want you to give me 8 plus or minus the square root of something, all divided by 4. And just leave it like that. That will be your answer that you guys submit to me. Okay? Let's see here. There's 3 practice problems here. I'd like you guys to give it a try. I'm not going to work these ones out in the video, but I do have the answers here for you. So for this first practice problem, the answer comes out to this, this, and this for these 3 here. Stop the video. I want you guys to try these. Identify A, B, and C. Plug them into the quadratic formula, okay, and see if you guys can work out and get the same answers that I got here. All right. After you guys have worked through those 3, come back to the video, and we'll go on to the next page. We only have one more thing to cover after this. We're actually almost done. We're making good time. All right, so you guys tried those 3 problems. That's good. The next thing we're going to talk about is something called the discriminant. Okay, grab another sheet of paper here. Okay, next thing we're going to talk about here is the discriminant. This will be the last thing that we really go over for now. Discriminant. I can spell this. Discriminant. Okay, so we have the quadratic formula, which is x is equal to. Let's try that again. So we have the discriminant, and we have the quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is this part here underneath the underneath the square root. It is this b squared minus 4ac part. Now there's a reason why this is, or why this happens to have the characteristics as it does. I'm not going to go into the theory with you guys in an Algebra 2 class, but there is some very special properties that come from knowing something about this value. Here is technically what we're going to be doing. So the discriminant. This is all here on this page. If you guys are, this is the second to last page in the packet that I gave you guys. Ms. Karp has got 4 of these listed out. We're only going to look at 3 of these. We're going to look at all 4 of them, but I'm going to take these 2 and I'm going to combine these 2 together, okay, for our purposes. And then these last 2 we'll talk about. So the rules that you need to know here: if the discriminant, so if b squared minus 4ac, if this is a greater than 0, which we want, if this is a positive number, is really what this says here. So if this is a positive number, then you will have 2 roots. Okay, so this means that you have a quadratic that somehow, some way crosses the x-axis at 2 points. Okay, that's what this is. Okay, the next one is when it is equal to 0. So if we have b squared minus 4ac is equal to 0, so that means that this part here works out to 0. We're taking the square root of 0, which means it doesn't matter. And then when we do plus or minus, we're doing the plus minus of 0, which means whatever value you get for negative b over 2a is just going to be that, and you're not going to have the second value here. So you're not going to do the plus minus case where we do those 2 separate numbers. This is going to lead to a single root. This is the graph when you have a single root on the x-axis and then your parabola coming off of it. So it just kisses the x-axis and then it bounces off. Okay. The last case we have here is b squared minus 4ac equal to, let's try it again, less than, this should be less than, is less than 0. Okay. This is one where you have no roots. Okay. This is, well, no real roots. Let's adjust that here. For our purposes in this class, this is the no real roots case. For our purposes, it's no roots or no solution. In reality, it's the no real roots case. So that is when, if you are having a graph, you'll have a parabola, and the vertex will not be sitting on an x-axis, and you won't be even touching the x-axis. This, when this happens, that means you have a negative under here, and we can't take the square root of negatives in the real numbers. This ultimately leads to what we call imaginary numbers, or specifically complex numbers, which we are not going to deal with in this particular class. You guys will probably see it again next year for most of you when you guys take math analysis. You guys will see complex and imaginary numbers in that class. But these are the general rules. You will see questions on this where they ask you to calculate the discriminant and then figure out how many roots you're possibly going to have. So you'll either have 2 roots, 1 roots, or no roots. Okay, will be your 3 possible possibilities for that. There are some examples in here. I'm not going to run through these examples, but you guys are welcome to try it. You can check your answer on this, figure out how many roots you've got here. I won't figure it out, but if you figure out how many roots you've got built upon these specific answers here, and then you can graph it in your graphing calculator on Desmos and just count the number of times that it crosses the x-axis. The number that you get for the number of intersections should match up with whatever you get for your discriminant when you guys follow through with it. All right, your homework assignment is going to be, where did it go? I lost it. Here it is. Your homework assignment is this here, page 318, number 15 through 23 odd, 29 through 32, and 34. And that's that. Cool. We're all done. Thank you, guys. I'll see you guys next class.